When we look at city streets today, we see cars, buses, concrete, and people staring at their phones. When we visit a zoo, we see lions, elephants, and birds, but no living dinosaurs behind glass. When a child plays with dinosaur toys, they imagine T-Rex roaring through modern cities, chasing humans and trucks. And when we watch movies, we see a fantasy world where humans and giant dinosaurs exist side by side. But here's the strange part. Our real planet once did belong to dinosaurs for more than 160 million years. Today, we walk on the same Earth, under the same sky, with the same gravity, but the rulers of the land are gone. So a simple question becomes a very powerful thought experiment. What if that asteroid, 66 million years ago, had missed? How different would Earth be? Would humans exist at all? Or would our cities belong to something else entirely? But why does this question matter so much? Because it forces us to ask, how fragile is our history? Was our rise to power on Earth guaranteed, or just a lucky accident in a much bigger story? Open your mind. Follow your curiosity. Welcome to the Center for Curiosity. Before we imagine a world where dinosaurs never went extinct, we need to understand the basic story of what actually happened. Here is the simplest way to look at it. Dinosaurs ruled the land for a very long time. Not just a few million years. For around 160 million years, from the Triassic period through the Jurassic and into the Cretaceous, dinosaurs were the dominant large animals on land. They came in many shapes and sizes, from small bird-like hunters to giant sauropods longer than a blue whale is today. During this time, early mammals already existed, but they were small. Most were about the size of a mouse or a rat, living in the shadows, active at night, trying not to be eaten. We often imagine a clean before and after story. First dinosaurs, then mammals. In reality, they overlapped for tens of millions of years. Dinosaurs on top, mammals far below. Then, about 66 million years ago, something dramatic happened. A huge asteroid, more than 10 kilometers wide, slammed into what is now the Yucatan Peninsula in Mexico. The impact released energy like billions of nuclear bombs, throwing dust and vapor into the atmosphere, causing fires, shock waves, and a rapid climate disaster. This event is called the Cretaceous Paleogene, or KPG extinction. Almost all non-avian dinosaurs died out. Non-avian just means dinosaurs that were not birds. Because here is an important fact. Birds are actually the last surviving dinosaurs. So when we say, what if dinosaurs never went extinct, we really mean, what if the big land dinosaurs, the ones we imagine in movies, had not died out in that mass extinction event? After that extinction, mammals began to change very quickly. Without giant dinosaurs eating the plants and filling most of the big animal roles, there was suddenly ecological space for mammals to grow bigger, try new diets, and occupy new environments. Within a few 100,000 years, some mammals had already grown from rat-sized to dog-sized, and later to even larger forms. Over millions of years, some of these mammals evolved into primates. Some primates evolved into apes. And eventually, one lineage of apes evolved into humans. This entire path depended on the world after the dinosaurs' extinction. So now we can ask our main question more precisely. If that asteroid had missed, or if the dinosaurs had somehow survived it, what parts of this story would change? Would mammals still rise? Would primates still appear? Would anything like humans ever exist? To explore that, we should first tell the story of how scientists came to understand this extinction and its consequences, because the way this idea developed will help us see what might have happened in an alternate timeline. A long time ago, before the word dinosaur even existed, people were already finding huge bones in rocks. They did not know what they were. Sometimes they called them the bones of giants or dragons. Only in the 1800s did scientists begin to understand that these were remains of a completely different group of animals that lived long before humans. As paleontology grew, more fossils were discovered all over the world. Scientists noticed something strange in the rock layers. In older layers, below a certain boundary, dinosaur fossils were abundant. In younger layers, above that boundary, there were no non-avian dinosaurs at all. It looked like dinosaurs had suddenly disappeared from the record. They also noticed that many other groups vanished at the same boundary. Sea reptiles, some kinds of plants, and many smaller creatures all disappeared at about the same time. Clearly, something big had happened. For a while, there were many ideas. Maybe slow climate change, maybe volcanoes, maybe disease. But in the late 20th century, evidence for an asteroid impact became very strong. Scientists found a thin layer of rock around the world that contained a lot of iridium, a metal rare on Earth's surface but common in some meteorites. They also found a huge impact crater called Chicxulub in Mexico, with the right age and size to match the extinction event. This combination strongly supported the idea that an asteroid impact triggered the KPG extinction. Over time, scientists also started to understand what happened after that event. By studying fossils of mammals, they saw that many species died out, but a few small, widespread species survived and then diversified very quickly. Within a relatively short period, in geological terms, mammals filled many of the ecological roles the dinosaurs had once held. This is important for our story, because it tells us that the extinction of dinosaurs was not just a sad ending for them. It was also the beginning of an opportunity for mammals. If we remove that extinction, or if we imagine dinosaurs surviving it, we remove or at least delay that opportunity. And that means the entire tree of life after that point might look very different. Now, let us move step by step into our alternate timeline. To keep things clear, we will ask three big questions. First, what would ecosystems on Earth look like if large dinosaurs stayed dominant? Second, what would happen to mammals in that world? And third, what are the chances that anything like humans or an intelligent civilization would appear? Here is the first key idea. Dinosaurs were not failing or fading away before the asteroid hit. Fossil evidence suggests they were still diverse and successful, filling many kinds of roles in ecosystems all over the world. In fact, some scientists describe them as being at their top of their game at the moment disaster struck. That means if the asteroid had missed or had been smaller, dinosaurs would likely have kept evolving and dominating for a very long time. What does dominating mean here? It means that the largest plant eaters and meat eaters on land would almost certainly still be dinosaurs, not mammals. Imagine herds of giant herbivore dinosaurs shaping the landscape, eating young trees and keeping forests more open. This is important because large herbivores are ecosystem engineers. They change what plants grow, how dense forests are, and even where fires happen. In our real timeline, after the extinction, forests and ecosystems reorganized. New plant groups, especially flowering plants, expanded, and mammals took advantage of these changes. In the alternate timeline, dinosaurs might have continued to control plant communities, which would change what habitats were available for mammals and birds. For example, some research suggests that when large dinosaurs vanished, forests became denser in some regions because there were no longer huge animals knocking down trees and eating saplings. If dinosaurs had stayed, many areas might have remained more open, more like savannas or park-like woodlands dominated by dinosaur activity. Let us use a simple picture. Imagine two planets. Planet A is our real Earth after the extinction. Large dinosaurs are gone. Forests and grasslands reorganize. Mammals slowly move into larger and larger body sizes. On Planet B, our alternate Earth, where the asteroid misses and giant dinosaurs survive. On this planet, sauropods, horned dinosaurs, and duck-billed dinosaurs still roam in large herds. They trample seedlings, knock over trees, and shape the vegetation by their feeding. On Planet B, any mammals trying to become large plant eaters would have to compete directly with these huge dinosaurs. That's not impossible, but it would be very difficult. In our world, after the extinction, some mammals quickly became medium and large herbivores, like early relatives of horses, rhinos, and elephants. In the dinosaur survival world, dinosaurs might keep that role locked down. Mammals would likely remain small to medium-sized creatures living in the spaces dinosaurs do not use, such as burrows, trees, or nighttime niches. So the first difference is clear. Earth's landscapes would still be dominated by giant reptiles, not large mammals. Our modern big animals like elephants, rhinos, and bison might never evolve in anything like their current form. Now, what about predators? In our timeline, large mammal predators, big cats, wolves, bears, eventually became the top hunters on land. But in a dinosaur-dominated world, many of those top predator roles would likely remain filled by large theropod dinosaurs, similar in size to tyrannosaurs or other big carnivores. That means mammals trying to evolve into big predators would again face serious competition. A wolf-like mammal would be living in the shadow of a much larger, faster, better-armed dinosaur hunter. So it might stay small, or focus on scavenging or hunting in more hidden environments. In simple terms, on a dinosaur-dominated Earth, mammals are likely to stay in the margins for much longer. They might still diversify into many species, but most would probably remain small, secretive, and specialized. Now we can approach the key question most people care about. In that world, what are the chances that something like humans would appear? This is a hard idea, so let us take it step by step. In our real history, human evolution depended on several things happening in sequence. First, mammals had to survive the extinction and diversify. Second, primates had to evolve in forests. Third, some primates had to move into more open habitats, eventually becoming upright, tool-using hominins. All of this happened in a world without giant land dinosaurs. Mammals could expand into many new roles without being constantly pushed back by towering reptiles. In a world where dinosaurs stay, this chain is broken or at least heavily delayed. Primates might still evolve, but they would be competing with dinosaur-dominated ecosystems at every step. One possibility is that primates never leave the trees in a major way. Large ornithopod dinosaurs and sauropod dinosaurs might keep the ground ecosystems busy, while big theropods dominate hunting. In that case, a creature like us, bipedal, ground-dwelling, building cities, might never appear at all. Another possibility is that an intelligent species does evolve, but it is not a mammal. Some scientists and writers have speculated about dinosauroids, hypothetical intelligent descendants of certain dinosaur groups, like troodontids, which had relatively large brains for their body size. This is very speculative, but it is not impossible. However, even if dinosaurs evolved, their bodies, senses, and behavior might be very different from ours. They might have different hands, different ways of speaking, and different needs for tools and technology. Civilization, if it appeared, might look nothing like human civilization. The key point is this: human-like intelligence is not guaranteed by evolution. It depends on a long chain of accidents, extinctions, and opportunities. In a world where dinosaurs never went extinct, that chain would be completely rearranged. So the most honest answer is, on such an Earth, humans are very unlikely to exist. Now that we have a basic picture of a dinosaur-dominated Earth, let us look at some exceptions and complexities. Reality is almost never as simple as dinosaurs win, mammals lose. Evolution is messy, full of small accidents and local surprises. First, even if giant dinosaurs stayed in control of many ecosystems, there would still be places where they were rare or absent. For example, on very small islands, at high mountain elevations, or in extreme climates, large animals often struggle to survive. In those kinds of habitats, mammals might still have room to experiment, grow larger, or fill unusual roles. Imagine a chain of islands far from the main dinosaur continents. If only small dinosaur species reached those islands, or none at all, mammals could become the top predators and herbivores there, just like they did in some real island ecosystems after the extinction. We might see wolf-sized or even larger mammals evolving there, in parallel with dinosaur-dominated mainlands. Second, climate and geography keep changing over millions of years. Continents move, sea levels rise and fall, ice sheets grow and melt. These changes can shuffle which groups are successful. Even if dinosaurs survived the original impact, later climate shifts could still stress some dinosaur groups and open temporary windows for mammals or even birds to expand. So the story is not dinosaurs forever, mammals never. The rule is, if dinosaurs never went extinct at 66 million years ago, they would probably delay or reshape the rise of mammals and humans, but local exceptions and later events could still produce surprising outcomes. Now, let us go deeper into some wow ideas, the kind that can change how we see our own reality. One deep insight is this: our existence depends on a very narrow window in time. Think of Earth's history as a long movie, perhaps 2 hours long. Dinosaurs fill more than an hour and a half of that movie. Mammals only start to rise near the last few minutes. Humans, as a modern species, appear in the last fractions of a second. In that movie, the asteroid at 66 million years ago is like a single, sudden scene change. Without it, the final scene might be completely different. Instead of humans talking into microphones, there might be intelligent dinosaur descendants doing something we can't even imagine. This leads to a deeper question. Is intelligence like ours a goal of evolution, or just one of many possible outcomes? Many biologists argue that evolution has no fixed goal. It simply explores possibilities, favoring whatever works well enough in each environment. In our world, big brains, language, and technology turned out to be extremely effective for one particular lineage of apes. But in another timeline, other traits, like extreme camouflage, chemical defenses, or even different forms of group behavior, could become the winning strategy instead. In a dinosaur-dominated world, it is not clear that large brains would always be the best solution. For a giant sauropod, having a bigger brain might be less important than having a more efficient gut or stronger legs. For a top theropod predator, sharper senses and faster reflexes might matter more than the ability to build tools. So our cleverness is not guaranteed. It is one path among many, made possible by a very specific and fragile sequence of events, including the dinosaurs' extinction. Here's another wow angle. Even in our real world, we can still see the shadow of dinosaurs in everyday life. Birds are living dinosaurs, evolved from one group of small feathered theropods. When a pigeon walks across a city street or a crow looks at you with intelligent eyes, you are seeing descendants of creatures that shared the planet with T-Rex. In a sense, we already live in a world where some dinosaurs survived, but only in smaller, lighter, flying forms. Now imagine a world where those bird dinosaurs shared the planet with their giant land-dwelling cousins for tens of millions of years. Flying dinosaurs dominating the skies, giant dinosaurs dominating the land, and mammals, if they exist at all, hiding in the margins. In that context, our modern world full of mammals, including us, starts to look like a very rare and unusual outcome. What about modern relevance? Why should anyone, living today, care about this what-if scenario? First, it helps us understand how deeply our lives depend on events we never see. When you walk into a city, everything around you, buildings, roads, electricity, even the coffee you drink, exists only because of a long chain of events in deep time. The dinosaurs' extinction is one of the major turning points in that chain. Second, it gives us perspective on current extinctions. Right now, human activity is causing many species to vanish faster than they would under natural conditions. We sometimes think, life will recover, it always does. And that is true. Life is resilient over millions of years. But the dinosaur story shows that when a dominant group disappears, the world that comes after is not just a repaired version of the old one. It's a new world with new rulers, new ecosystems, and new possibilities. If humans cause a major extinction now, we cannot assume that the future world will be comfortable for us or even include us at all. Third, this topic helps us stay humble. We often act as if humans were the goal of evolution, the natural endpoint of life's story. But in reality, we're more like a recent twist in a very long, unpredictable tale. If dinosaurs had not died out, this twist might never have happened. Now, let's briefly recap the main ideas we've explored so far. We started with a simple question. How different would Earth be if dinosaurs never went extinct? We saw that in our real history, an asteroid impact 66 million years ago triggered the KPG extinction, wiping out almost all non-avian dinosaurs and many other species. This opened ecological space for mammals to grow larger, diversify, and eventually give rise to primates, apes, and humans. In an alternate world where dinosaurs survived, they would likely keep dominating many ecosystems as large herbivores and predators. Mammals, instead of becoming elephants, whales, and humans, might mostly remain small and hidden, with only a few exceptions in special environments. We explored how this would reshape landscapes, food webs, and the chances of intelligent life evolving. The most honest conclusion is that humans are very unlikely in that timeline, and if intelligence did appear, it might belong to a very different kind of creature, perhaps an intelligent dinosaur or bird. We also saw that even speculative scenarios can teach us serious lessons about how extinction opens doors for new groups, how fragile our own history is, and how dangerous it is to assume that our existence was guaranteed. Now, let's circle back to where we began. When we walk through our cities today, there are no herds of giant sauropods blocking traffic. When we visit a park, there are no packs of feathered dinosaur predators hunting in the trees. When a child plays with dinosaur toys, they are imagining a world that could have been real, but is not. After this journey, we can see those everyday scenes differently. We understand that the empty space where dinosaurs might have stood is not just an accident. It's the result of one specific extinction event at one specific moment in deep time. An event that opened the door for mammals, primates, and eventually us. So the next time you see a bird on a power line, or a fossil in a museum, or a dinosaur in a movie, you can remember, we live in just one version of Earth's possible stories. Change one event, like the dinosaur's extinction, and everything that feels normal around you might vanish from the script. Now, here is a question to leave hanging in your mind. If another intelligent species watched our story from the outside, would they see us as permanent rulers, or just a temporary chapter, like the dinosaurs? If you enjoyed this explanation, consider subscribing for more curiosity-driven content.